Swayam Prabha. Digital India. Educated India.
Hello everyone. In the previous class, we discussed about rock mass quality index, that is Q system, as far as the classification of rock mass is concerned. So today we will learn about a new classification system for rock mass, which is called as Geological Strength Index. In short, this is also called as GSI. Today we will learn about this GSI and then we will see some of its application. So to start with, basically this RMR and Q systems, they are most popular rock mass classification systems, and we have seen that they make use of certain parameters which reflect intact rock properties and the characteristics of the joint. We saw that you had to use RQD, then joint roughness, joint wall strength and many such parameters for RMR and Q systems. These two systems were mainly developed for tunneling work, but they are also used for other purposes, and I mentioned to you that when you use it for other purposes, you need to be careful and one needs to use lot of engineering judgment while applying these two systems for other purposes like the slope stability analysis or the foundation analysis. The main difference between RMR and Q system was the weighting of relative factors. For example, UCS was not a parameter in the Q system, but it has some influence through the factor SRF, which was stress reduction factor SRF, and through this factor this UCS had the influence on the Q system. Otherwise, UCS was not there directly as one of the parameter. Now we have some of the failure criteria, and one of the failure criteria is Hook and Brown failure criteria. We will learn in detail about this little later, but for the time being, in order to make you understand about this index GSI, I need to introduce it here. So this Hook and Brown criterion is quite popular in studying the stability of rock mass in underground excavations, and it is given by this expression in which the sigma 1f prime and sigma 3f prime, they are major and minor principal stresses at the failure when you conduct the triaxial tests. Sigma Ci is the uniaxial compressive strength of the intact rock, and S and A, they are the parameters of this Hook and Brown criteria. They depend upon the rock mass characteristic, and also this MM, that is also one of the parameter. Now as far as this parameter S is concerned, it is equal to 0 for poor quality rock and equal to 1 for the intact rock, and this parameter A is equal to 0.5 for good quality rock and 0.65 for poor quality rock. This Hook and Brown constant M, which is here as this in this equation, so this takes separate value for intact rock as Mi and for the rock mass as mm. That means this criteria can be applied to intact rock as well as to the rock mass. The change will be there in its parameter. So, one of that is mm. So, right now this has been written for the rock mass. Now, before 1994, the parameters of Hook and Brown criterion, they were derived from RMR, assuming the dry conditions at the excavation with no adjustment for discontinuity orientations with respect to the project. But subsequently, as the research took place in this direction, this criteria was modified, keeping that in mind with the fact that using that RMR in the determination of Hook and Brown parameters was not that reliable for poor quality rock masses which had low values of RMR. So, keeping this fact in mind, the index GSI was introduced. This GSI is a number which is ranging from about 10 for extremely poor quality rock mass to 100 for extremely strong unjointed rock mass. So, here as GSI increases, it represents the better quality of the rock mass. In the beginning, GSI was defined as equal to RMR 76 or RMR 89 minus 5, where this RMR 76 corresponds to the value of RMR which were computed as per Binyavsky 1976, where the maximum rating for groundwater condition was assigned as 10. And this RMR 89 was the value of RMR as computed as per Binyavsky 1989, which we have already discussed in some of the earlier lectures. So, this GSI was introduced by Hook in 1994, and this system has heavy reliance on geological observation and less on the numerical values. So, let us see that what all are those geological observation on which this index GSI relies on. So, there are two major parameters. One is the surface condition of the discontinuity and another one is the interlocking among the rock blocks. Now, as far as surface condition is concerned, it varies from very good for the fresh unweathered surface to very poor for highly weathered or slicken sided surfaces with clay infill. I mentioned to you in some of the earlier classes that how the joint characteristic or the wall characteristic influence the characteristic of the rock mass, strength characteristic of the rock mass. So, here you can see that if we have the very good surface condition, this represents the fresh unweathered surface, and if we have very poor surface condition, it represents highly weathered or slicken sided surfaces with the clay infill. Now, as far as the second parameter is concerned, which is interlocking among the rock blocks, it can be defined as massive at the upper end of scale to crushed or laminated towards the lower end of the scale. So, basically on the basis of these two parameters, mainly this GSI is determined. So, the 6 main qualitative rock classes are there, which are defined as intact or massive, blocky, very blocky, blocky or folded, crushed and the last one is laminated or sheared. As far as the discontinuities are concerned, they are classified into 5 surface conditions, which are very much similar to the joint condition that we discussed when we had the discussion about the rock mass rating or RMR system. So, basically here it is 6 and here it is 5. So, we have 6 by 5 matrix, and out of this 6 by 5 matrix, based upon these two parameters on which this index rely on, we pick the block, and these conditions, they depend upon the actual and undisturbed rock mass classification and the discontinuity surface condition. And from this matrix, which is 6 by 5 in size, we find out the corresponding range for GSI. How this is done, I will be explaining this to you in a short while. There is going to be the drastic degradation in GSI, RMR and Q values, which occurs in the opening after squeezing or the rock burst. So, we need to evaluate the GSI of the rock mass in the undisturbed condition, and that only we should use. So, when the excavation takes place, if that excavation is through, let us say, squeezing ground condition, or if there is a release of immense energy, which phenomena is called as the rock burst. So, in that case, we do not need to consider the conditions which are there after the excavation, but we should evaluate the GSI on the basis of the condition of the rock mass which was there in the undisturbed situation. Take a look at this picture where you have the matrix 6 by 5. How? See here, you have 6 rows, 1, 2, 3, 4, 5 and 6, and these rows, they correspond to intact or massive, blocky, very blocky, blocky, disturbed or semi disintegrated, and laminated or sheared. As I mentioned, that 6 conditions on the structures of the rock mass. And then take a look here along the column size, you have the 5 columns, 1, 2, 3, 4 and 5, and these represent the surface quality, and in this direction the surface quality decreases. That means here you have the very good quality of the surface, that means it is very rough, fresh and unweathered surface. Then the next one is the good surface condition, which signifies rough, slightly weathered, iron stained surfaces. Third one is the fair surface condition, and it is representing smooth, moderately weathered and altered surfaces. Then you have poor and very poor surface conditions. So, we need to use this matrix judiciously for crushed, disintegrated and laminated shear rocks, especially you see this portion where it is written not applicable. So, hard, thick laminated rocks in the last row means this one may not be applicable because they may have higher strength classification which cannot be taken care by this index GSI. This GSI is one of the parameters which is used in assessing the strength and deformability of rock mass using Hook and Brown failure criterion. So, depending upon the structure of the rock mass and the surface condition, you have seen that 6 by 5 matrix, and whatever is the condition that is relevant in the field, you go to that chart and pick the range corresponding to those field condition, pick the range for GSI. Now this GSI is related to Hook and Brown failure criterion parameters, that is M, S and A, and this is related empirically. The relationship between Hook and Brown parameters for the rock mass and the intact rock is given by this expression, and this expression is valid for GSI greater than 25. So first we go to the field, we take the observations there, and then depending upon if the value of GSI is greater than 25, here we can find out the Hook and Brown parameter for the rock mass, which is mm, using this value of GSI which we have obtained from the field condition and that 6 by 5 matrix. This expression also makes use of the Hook and Brown parameter for the intact rock, which is Mi. Various values of M for the intact rock is given here. You can see that for the limestone it is 5.4, dolomite 6.8, and likewise for sandstone you see it is so high 14.2, and for granite it is even higher, it is 27.9. So you know that the granite has better shear strength characteristic, and therefore you are having the larger value of this parameter M in case of the better quality rocks. Now for good quality rock mass, that is if you have GSI more than 25, A is going to be 0.5 and S can be obtained as exponential of GSI minus 100 upon 9, and for poor quality rock mass A is going to be 0.65 minus GSI upon 200 and S is equal to 0. This Q system also can be used to derive GSI, and the assumption which is involved while doing so is that the excavation is going to be dry. So we obtain the modified Q using this expression RQD upon Jn multiplied by Jr upon Ja. If you recall our earlier discussion, we saw that this Q index had 3 quotient, and there was one more quotient with these 2 which was having the factor SRF also. So here we assume that the excavation is going to be dry, and accordingly the ratings to these are assigned, and this GSI can be determined by making use of this Q prime in this particular manner, that is 9 natural log of Q prime plus 44. So once we obtain this GSI, I can find out the parameters of Hook and Brown failure criterion. Now based upon the values of GSI, the quality of the rock mass can be determined. If the GSI value is less than 20, the rock mass is called as very poor. If it is varying between 21 and 40, this is poor. If it is 41 to 55, it falls under the category of fair rock mass. If it is 56 to 75, it is the good quality of rock mass, and for very good quality of the rock mass, the range of GSI varies from 76 to 95. So, based upon these two parameters, that is the structure of the rock mass and the surface condition, we can make use of that 6 by 5 matrix and find out the range of GSI for that particular rock mass, and this value of GSI will be used to obtain the parameters of the Hook-and-Brown criteria, which is one of the most popular failure criteria in case of the rock mass. So, this was all about that I wanted to discuss with you as far as engineering classification of the rocks and rock masses are concerned. So, in this chapter we learnt about the engineering classification of the intact rock that was done using D. Ray and Miller classification system. Then we discussed in detail 3 classification system for the classification of rock mass. These include RMR system, Q system and GSI. Along with these classification systems, I discussed with you that what all are the limitations of each of these, and we also learnt about some of the application of these classification system. So, in the next class we will start our discussion on a new chapter which will deal with the strength behavior of isotropic and anisotropic rocks. Thank you very much.